Welcome, focused learners, to this advanced strategy explainer. Imagine you are sitting in the exam hall. The clock is ticking down. You flip the page, and there it is. A massive, multi-part Cambridge mathematics past paper question staring back at you. Whether you have built your foundations in syllabus codes like 0580, 0606, 4024, 4037, or 4040, it all culminates right here in the Cambridge 9709 Advanced Syllabus. Today, we are dissecting the exact strategies you need to conquer one of the most notoriously tricky areas of advanced trigonometry, the r sine theta plus or minus alpha and r cosine theta plus or minus alpha forms. We often call these the harmonic forms. Now, let's set the stage with two typical students we see every single year. First up is Alex. Alex is a hard worker, but under pressure, Alex completely overloads the exam paper with raw mathematics facts, dumping every single compound angle identity onto the page with zero structured analysis. Then we have Sam. Sam gets overwhelmed by the ticking clock, rushes through the algebra, and completely misses the specific command word requirements hidden in the question prompt. Over the next few minutes, we are going to read the warning signs, uncover the hidden examiner traps, and transform the flaws in Alex and Sam's approaches into your ultimate mathematics success blueprint. Okay, let's dive into this reality check straight from the grading room. The senior examiner reports highlight a very stark truth. The difference between a B and an A star in mathematics often comes down to how well you understand these specific harmonic trigonometry forms. This is not just some dramatic motivational statement. This is a cold, hard, statistical reality. The stakes for this specific topic are incredibly high. It represents a massive grade gap. Let's look at Alex's approach again. Just throwing raw facts at the paper, writing down r equals the square root of a squared plus b squared without actually showing the logical, algebraic progression, that gets you stuck at a solid B. The examiner cannot see your thought process. And Sam is rushing, finding the angle alpha in degrees when the given domain in the question was strictly written in radians. That mistake literally bleeds marks away. The gap between a good student and an elite, top-tier A-star candidate isn't about natural, born genius. It is entirely about understanding exactly what the Cambridge examiner is looking for when they construct these harmonic form questions. We are going to fix these errors right now. To get you operating at that A-star level, we have a meticulously structured journey for this session. First, we are going to explore the A-star difference and unlock the actual method. Second, we will lay down the theoretical foundations of the math itself. Third, we introduce the procedural framework, your step-by-step answering blueprint. Fourth, we dive into evaluation and analysis to get you thinking exactly like an examiner. And finally, we will cover the top examiner warnings that you absolutely must avoid. Let's kick things off with Section 1, the A-star difference, unlocking the method. The core problem we see every single exam cycle is that students rely way too heavily on raw, rote memorization instead of a structured methodology. Yes, you can memorize the shortcut that tangent alpha equals b over a, but if you just write those raw numbers down without showing the expansion of the compound angle, without explicitly equating the coefficients clearly on the page, the examiner literally cannot see your analytical process. The remedy to this is what we call the method mark strategy. In Cambridge 9709 papers, examiners explicitly award marks for your analytical journey. Getting the final math fact correct might earn you a single accuracy mark, an A mark, but the bulk of your grade comes from the M marks, the method marks. The key to making that massive jump from a B to an A star is deeply understanding how to format your logic. When you explicitly write out that A cosine theta plus B sine theta is identically equal to R cosine of theta minus alpha, and then you write out the expanded form right below it, you are actively communicating with the examiner. Before we continue, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving right along to Section 2, Theoretical Foundations, building the architecture of your mathematical understanding. Top-performing students do not just see this trigonometry topic in isolation. They exhibit a highly connected conceptual understanding. Think about it. The r sine and r cosine forms are not just a random algebraic trick. They are a fundamental mathematical bridge. They take a complicated, messy wave function made of two separate overlapping waves, a sine and a cosine, and synthesize them into one single, elegant, easy-to-read wave. The Cambridge syllabus targets distinct cognitive domains here. Knowledge, understanding, application, and deep analysis. They prioritize analytical depth over superficial breadth. This means they are going to ask you to apply these principles to completely unfamiliar context in the exam. They won't just ask you to convert the form. They will ask you to use that synthesized wave to find the maximum temperature in a complex trigonometric modeling question. To tackle this, top students use a framework adapted for math, very similar to analytical writing. We call it PEAL: point, evidence, explanation, link. Your point is stating the correct harmonic form. Your evidence is the compound angle expansion. Your explanation is the algebraic equating of coefficients. And your link is substituting this back into the original complex equation to solve it. So, the absolutely crucial point here is cross-topic integration. Principal examiner reports consistently, year after year, show that candidates who reference cross-topic connections achieve significantly higher marks. What does this actually mean for Rsin and Rcos forms? It means connecting this trigonometry directly to calculus. You might get a 9709 question asking you to find the maximum or minimum value of a function. Sure, you could use differentiation, find the derivative, set it to 0, and solve. But recognizing that transforming the expression into an Rcos form gives you the maximum value of R instantly, that is a profound display of cross-topic fluency. That is what gets the examiner nodding their head in approval. Mastering these core theoretical principles, using precise definitions, understanding why one step leads to the next, and integrating your knowledge across the entire syllabus builds an impenetrable defense against those sneaky trick questions. Now we enter the core of our strategy. Section 3, Procedural Framework, the anatomy of a perfect answer. Let's walk through this standardized sequence with absolute laser focus. This is exactly how top-tier A-star candidates systematically process these forms under immense time pressure. Step 1. Identify key elements. Decode the command words. Are you turning it into a sine or cosine form? Is the identity plus alpha or minus alpha? Step 2. Apply relevant principles. Physically write down the correct compound angle identity from your memory or the formula booklet. Step 3. Execute analysis with clear working. This is where Alex failed. You must equate the coefficients. If you have 3 sine x plus 4 cosine x equals r sine x plus alpha, you must explicitly write r cosine alpha equals 3 and r sine alpha equals 4. Do not skip this. Step 4. Verify results. Check your quadrant. If your tangent alpha calculation comes out negative, you better stop and ask yourself which quadrant you are actually in. Step 5. Present in appropriate format. Check the domain. Are we in radians or degrees? Are we rounding to 3 significant figures or exact surd values? If you were to take one of Sam's rushed, messy answers right now and rewrite it live using this exact 5-step sequence, those red pen marks would instantly transform into green check marks. You are building a foolproof sequence. Step 5 requires what we call strict presentation conventions. Practical application of these rules develops professional mathematical skills. And let me tell you, Cambridge examiners are strictly looking for these conventions to award full marks. You need to use proper headings when you are defining R and alpha. Apply correct terminology. Don't just vaguely say the angle is 30 degrees. Specify where alpha is the acute angle. Maintain appropriate formats. If the question gives the domain as 0 to 2 pi, your alpha must be in radians, no exceptions. Providing clear, logical annotations in your working out guides the examiner's eye down the page. It makes it literally impossible for them to miss your method marks. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Welcome to Act 4, Section 4, Evaluation and Analysis. This is where we start thinking like an examiner. This slide brilliantly illustrates the exact difference between the candidates. It is time for our interactive workshop, Challenge 1, Data Scan. Imagine a complex 9709 function on your screen right now. f of x equals 3 sine x plus 4 cosine x. You have 60 seconds on the clock. An average candidate like Alex might just guess the core trend or state facts without context, writing maximum is 5, without any logical links. But a top-scoring candidate justifies decisions with evidence. They evaluate the core trend instantly by visualizing the R form. They calculate R equals the square root of 3 squared plus 4 squared, which is 5. They formally write out, f of x can be expressed as 5 sine of x plus 0.927 radians. Therefore, since the maximum value of a pure sine wave is 1, the maximum value of f of x is exactly 5 times 1, which is 5. Challenge 2, find the flaw. Listen to this sentence from Sam's exam paper. I found alpha is 53.1 degrees, so the maximum occurs when x plus alpha is 90. What is the flaw?
Sam didn't check the domain. If the question was in radians, Sam just lost the final accuracy marks. Top candidates consider all perspectives and strict domains. This level of critical evaluative thinking applies perfectly when you are comparing different mathematical methods during your exam. Often, you'll have the option to solve a tricky trigonometric equation using the Rsin form, or alternatively by squaring both sides to form a hidden quadratic equation in terms of sine or cosine. Let's do challenge 3, speed writing. You have 30 seconds to mentally draft a peel paragraph explaining why one method is better. Go. Okay, here is the examiner's perspective. A strong comparative analysis means evaluating the quality of your evidence. If you choose to square both sides of the equation, you introduce a massive limitation. You create phantom, extraneous solutions that aren't actually valid. You then have to waste precious exam time checking every single answer. But if you use the Rsin harmonic method, you avoid extraneous solutions entirely. Therefore, drawing a conclusion about relative importance, the harmonic form is vastly superior, significantly faster, and much safer for solving linear combinations of sine and cosine under time pressure. Before we hit the absolutely crucial top examiner warnings, here is a highly effective, game-changing study tip straight from our source materials: the memory hack. Use a visual story method to encode these complex R-sine and R-cosine concepts into your brain. Visualizing spatial information heavily aids in remembering strict analytical steps. For example, do not just memorize the algebra. Imagine a physical right-angled triangle. The horizontal base of your triangle is your cosine coefficient. Let's call it A. The vertical height of your triangle is your sine coefficient, B. The long hypotenuse? That is R, scaling the wall. And the angle of elevation from the base? That is your alpha. By picturing this literal physical triangle in your mind's eye during the exam, those abstract, messy algebraic formulas suddenly become a solid, visual, geometric reality. It makes calculating R and tangent alpha completely intuitive rather than just a memory test. We have arrived at the final and most important phase. Section 5. Top examiner warnings. Avoiding common pitfalls. Now, what is really fascinating about this specific list is that these are not just minor accidental slips. These are massive, grade-sinking pitfalls reported by the principal Cambridge examiners themselves year after year. Mistake 1, confusing cause and effect. Students often try to expand the given algebraic expression backwards rather than setting up the correct identity first and cleanly equating the coefficients. They completely lose the logical mathematical thread. Mistake 2, forgetting to check format and presentation. Imagine doing all the hard algebraic work. You perfectly find R and alpha, but then you rush and write alpha to one decimal place instead of the Cambridge-mandated 3 significant figures. Or you leave it in degrees when the paper explicitly asks for radians. You lose the marks! Mistake 3, writing answers that are not specific to the given context. If the exam asks for the minimum temperature in a greenhouse modeled by an R cosine function, and you just write -5 on the answer line, you haven't answered the context. You need to relate that mathematical minimum back to the specific time of day requested in the prompt. I need you to internalize this examiner alert with the serious, authoritative weight it deserves. Quote, candidates consistently confuse key terminology. Always define terms before using them in extended responses. Skipping your definitions or failing to explicitly state your exact R and alpha values clearly on the page before substituting them back into an equation is the absolute fastest way to bleed method marks. If you just magically produce a combined trig equation out of thin air without showing the examiner exactly what compound angle identity you used, you are literally throwing your A-star out the window. The Peel strategy works, the method mark blueprint is proven. But the actual execution requires your relentless dedication to showing your work clearly. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
Let's bring this entire system together with one final, crucial question. Is your current revision strategy relying purely on rote memory, or are you actively practicing the method mark strategy to secure your A-star? If you are just staring at textbook formulas hoping they stick, like our character Alex, you are preparing to fail. You need to actively practice structuring your answers, deliberately equating your coefficients, and meticulously verifying your quadrants and domain formats. Overhaul your study habits based on the framework we built today. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let any other exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.